Hey everyone, welcome back to the channel. Today I'm happy to share something fun. We're running one of the most powerful AI models available right now, Gemma-3-27B, on Kaggle T4 GPUs for free. Just a month ago, this would have required much more expensive hardware. But thanks to Google's recently released Quantization-Aware Training, or QAT Gemma-3, we can now run these massive models on T4 GPUs, which is totally free. This is a game changer for AI accessibility. If you've been frustrated by the hardware requirements of cutting-edge AI models or thought you needed cloud credits to experiment with the best models, this video is specifically for you. I'll walk you through this Kaggle notebook that demonstrates how to set up llama.cpp and run the Gemma-3-27B model on T4 GPUs. Before we get into the code, let me explain why this is so exciting. Gemma-3 is Google's latest generation of open models, released just last month. These models deliver state-of-the-art performance that rivals much larger models from competitors. The challenge has always been that models of this size require enormous amounts of GPU memory. The full Gemma-3-27B model, in its native B-float 16 precision, needs a whopping 54 GB of VRAM. That's beyond even high-end consumer cards like the RTX 5090. This is where Quantization-Aware Training comes in. Think of quantization like compressing a high-resolution image. Instead of using 16 bits to represent each number in the model, B-float 16, we can use just 4 bits int4. That's a 4x reduction in memory requirements. The Gemma-3-27B model shrinks from 54 GB down to just 14.1 GB, now within reach of consumer GPUs. But usually, this kind of compression comes with a significant performance hit. The magic of QAT is that it incorporates the quantization process during training, making the model robust to lower precision. The result? A model that maintains impressive performance while requiring a fraction of the memory. Looking at this Kaggle notebook, we can see it's divided into a few key sections. Let's go through each one. First, we check what GPUs we have available with NVIDIA SMI. We can see we have 2 Tesla T4 GPUs, each with about 15 GB of memory available. That's perfect for our quantized model, which needs around 14 GB. Next, we're using a pre-built version of llama.cpp with NVIDIA GPU support. Llama.cpp is an incredible project that allows efficient inference of large language models on consumer hardware. I built it using the Kaggle container and uploaded the build folder as a Kaggle dataset. We need to copy these executables to a writable directory and make them executable. Now comes the fun part, testing what this model can actually do. Let's look at this image understanding example. We download an image of origami animals and ask the model to describe it. The response is impressively detailed. It accurately identifies the orange origami animals, describes their shadows on the wall, and even picks up on composition elements like lighting and color palette. This level of multimodal understanding used to be limited to much larger models or specialized systems. The next section shows how to set up llama.cpp as an OpenAI-compatible API server. This is critical because it means we can use the same code and tools we'd use with OpenAI's API, but running entirely on our local hardware. The server takes a bit of time to load the model into memory, but once it's running, it's pretty fast to respond to requests. Finally, we see an example of generating a creative writing piece, a short sci-fi story about the moon. The quality of the text is remarkable, with a coherent narrative arc, descriptive language, and even emotional resonance. This isn't the choppy, inconsistent text you might expect from a heavily compressed model. It's fluid, creative, and engaging. Let me break down what's happening under the hood here. When we initialize the server, you can see all these parameters being loaded: context length, attention mechanisms, layer counts, and so on. This is a glimpse into the architecture of Gemma-3. What makes this possible is that the Gemma-3 model was specifically trained with quantization in mind. The developers applied QAT on approximately 5,000 training steps, using probabilities from the non-quantized checkpoint as targets. This reduces the complexity drop by an impressive 54% compared to standard post-training quantization. Another key optimization is the efficient use of GPU. Notice the NGPU layers is set to 100. This tells llama.cpp to offload all the layers to the GPU, significantly speeding up inference. In the end, we can see some benchmark numbers: 87 input tokens per second and 12 output tokens per second, pretty decent generation speed. So what can you actually do with this setup? The possibilities are enormous. You can create sophisticated chatbots for customer service or personal assistants that respond intelligently to complex queries. You might want to build content generation systems that help with creative writing, marketing copy, or technical documentation when you're facing writer's block. Image understanding is another fantastic application. Think accessibility features for visually impaired users, content moderation tools, or advanced media analysis. With this local setup, you can experiment with fine-tuning the model for specialized domains without spending a fortune on cloud resources. And of course, you can dive deep into prompt engineering research, testing different techniques on a truly powerful model right on your own machine. The ability to run these models locally also gives you complete privacy. Your data never leaves your machine, which is crucial for sensitive applications. Running a 27 billion parameter model used to require significant investment. Now, thanks to Kaggle-free GPUs, Google's Q8 Gemma, and efficient inference engines like llama.cpp, these powerful models are accessible to individual developers, researchers, and hobbyists. This democratization of AI is going to accelerate innovation in ways we can't even imagine yet. When powerful tools become widely available, we see creativity flourish and new applications emerge. If you found this tutorial helpful, please subscribe to the channel for more content on cutting-edge AI technologies and how to use them practically. Drop a comment letting me know what model you're most excited to run locally, or if you have questions about getting this set up on your own hardware. Thanks for watching, and I'll see you in the next video where we'll dive deeper into fine-tuning these models for specific applications. Until then, happy coding!